In this video, we're going to be looking at inverse trig and some obtuse triangle problems. So kind of the motivating question here is that here you've got yourself a right triangle. You see that the legs are 3 and 4. So, if you're paying attention last time, you could see that the hypotenuse is going to be 5. So we know this triangle. But what are the angles? Right? We have to know it because we know that sine of theta is, like 3 over 5, or tangent of theta is 3 over 4. We know the shape of this triangle, so we're just going to have to kind of do some research, kind of look up what theta gives us sine of theta equals 3/5, or tangent of theta equals 3/4. And so that's where we're going to use inverse trig. Now, in the old days, what you would have done is you would have said, okay, well, sine of theta is equal to 3/5, and then you would have gone and gotten your trig tables, and you would say, okay, I know that sine of theta is 3/5. That's about 0.6. Okay, so over here, I see 0.7. Okay, I'm going to have to go back to sine, getting to 0.6. Okay, here, it's not going to let me write on it. Here, use the highlighter. Yeah, okay, so 0.6 was, right there. It's where sine equals 0.6. So you go back and you think it's about 37 degrees. Okay. Now, we've got the calculator, and it can basically look up on these tables and figure it out. Okay. Another way we could have done it was that we could have said tangent of theta is equal to 3/4. Okay, so we're looking for 0.75 in the trig table for tangent. Okay, so 0.75, closest thing, again, right here, 37 degrees. Okay, but you're not going to be using a trig table in this class. Nobody uses trig tables anymore because we've got calculators. So what I'm going to do, I'm going to bring in the scientific calculator, and I'm going to use what we would call inverse sine. And now in other classes, I would probably call this arc sine. I don't really know enough about trig yet to know why you would call it arc sine. What about trig? Trig is about triangles. Arc sounds like part of a circle. Like what's the connection there? We don't really know that yet, so we're just going to call it inverse sine for now. And then over here, I'm typing it in. Inverse sine of 3/5. What do you know? About 37 degrees. Right? Okay, so all of these pieces of evidence are showing us the same thing. Theta is about 37 degrees. So the first example I've got for you, very similar. Okay, I've got some kind of triangle, and we want to find the angle. We're given an opposite and a hypotenuse. So that's like so in SOHCAHTOA. So we're going to need to use sine. Okay, so I kind of gave you some scaffolding here. Give you the first step is you're going to write down what is sine theta. Sine is opposite over hypotenuse. That's 2 over 5. Now, this is an algebra class, right? So we're always looking to, try to solve for x or solve for theta by doing the same thing to both sides of an equation. So what we're going to do is we're going to take the inverse sine of both sides of this equation. Okay, so inverse sine of sine of theta is equal to inverse sine of 2/5. Now, the inverse sine of sine, well, that's like the square root in squaring, or e to the x and natural log of x. They undo each other. So what we're going to do is we're going to say, okay, that, they undo each other. And I could say theta is equal to the inverse sine of 2/5. Bring in a calculator. Over here. And we're going to do inverse sine of 0.4. That's 2/5. That's 23.578. So that's 23.578 degrees. Okay, that's how we're going to do it. Really important to remember that you need to make sure your calculator is in degree mode for this. Okay, otherwise you would be pulling back some number of radians. We don't know what radians are yet, so that wouldn't be good for us. And I think in this class we're going to want to round to 3 decimals. I think that's what the instructions are on the quizzes. Alright, and here's one that'll be a good one for you to try on your own. Okay, notice that I've got an adjacent side and a hypotenuse, so I'm going to need to use cosine. I'll need to use inverse cosine eventually to find the measure of angle theta. I'll kind of get you started with that first step. Right, first we started with, okay, I know I have an adjacent and a hypotenuse, and cosine is adjacent over hypotenuse. So I'm going to say cosine of theta is equal to 4 over 11. And now I'd like for you to try to, take it the rest of the way yourself. If you're watching on the video, you're going to want to pause because I'm just going to pause the recording and, the answer's just going to flash up in a second. Okay, so you work it and check your answer against mine. Alright, there you go. So you can see I said, okay, if cosine of theta is 4/11ths, then theta is the inverse cosine of 4/11ths. Theta is the angle whose cosine is 4/11ths. That's really what it means, inverse cosine. The angle whose cosine is 4/11ths. Okay. Now, I didn't just know what the inverse cosine of 4/11ths was. I brought in a calculator, so I'll show you what I did. There it is. I called on inverse cosine, typed it in just like I saw it. You don't really need that extra parenthesis unless you're going to use this with something else. And then that's where I got 68.676 degrees. Okay, so let's make sure you're in that degree level. Here's another one for you to try on your own. Okay. I'm going to find the measure of angle theta. Okay, I've got an opposite and an adjacent. That's OA, so that's TOA, right? We're going to use tangent, inverse tangent. And I think this one, I'm going to work this one, but I'm not going to pause the video. So if you're struggling to see like my kind of thought process here, I'm going to work it. I'm just not going to narrate it. So if you do want to try this on your own, just look away. Okay, so what I did, started with tangent, right? Said the tangent is 10 over 13. You can see that from the diagram. And then I did the same thing to both sides. I took the inverse tangent of both sides of that equation. Right? This algebra class, you got to be fair to both sides of the equation by doing the same thing to both sides. So I took inverse tangent of both sides. Inverse tangent of tangent theta is just theta. And so theta is inverse tangent of 10 over 13. Go to the calculator for that. You get 37.569 degrees. Now this one's a little more complicated, right? We're asking you to solve the triangle, and remember from last time that's like find everything that wasn't given. So we're going to want to find the length of side C. We're going to want to find the measure of angle A, and we're going to want to find the measure of angle B. It might be good to just write down what the measure of angle C is, even though that's pretty easy. So I might as well start with the easy stuff. Okay, so I'll just say measure of angle C is going to be 90 degrees for sure. And I could say there's a bunch of different ways you can solve this triangle. To get the length of side C, you could use trig. We don't have the angle yet. So what I might do instead is I might use Pythagorean theorem. Okay, so let's start with a squared, 6 squared, plus b squared, which is 10 squared, is equal to c squared. So that's 36 plus 100 is c squared, meaning c is the square root of 136. That's an exact answer. If you feel like you'd rather have a decimal answer, that's fine. Not a big deal. I'm going to leave this as square root of 136 so that I can, well, I guess it actually doesn't matter because I'm going to, when I go to find the angles, I'm definitely going to use the 6 and the 10 that I'm given, right? That's the safest thing, is to always use the given information, and as little as possible, use the thing that you calculated yourself. Because, like, I don't know, what if I made an error here? You know, you wouldn't want to depend on that number when you've got these that you know are factual. So I'm bringing in the calculator, and I need to take the square root of 136, and that's 2 root 34. Thanks. You might be thinking, that's not very helpful. Okay? What you want to do when this happens is you want to switch the mode in the calculator down to classic, so it'll give you a decimal. Okay, so I'm going to just enter the same thing. Oh, no, I didn't like that. Square root of 136 is going to be 11.662. That kind of makes sense, because we know that 11 squared is 121, and 12 squared is 144, so, you know, somewhere in there, 11.662. Now, to find the measure of angles B and A, I'm going to need to use inverse trig. Okay, well, I'll start with B. Okay, so I know that tangent of B is equal to opposite over adjacent, okay, meaning that B is inverse tangent of 6 divided by 10 is 0.6. So I will bring in the calculator, and I will run inverse tangent of 0.6. That'll be 30.964 degrees. Now, if we're really confident in our work there, I could find the measure of angle A by just doing 180 minus 90 minus the measure of angle B. Okay, so I can do that. I'll get 59.036. I'm also going to show you a different way you could have done this, right? You could use our shiny new trig. We can use this inverse trig. Well, I could say that, you know, maybe I'll also use the 11.662 just to show you that it all works. I'll use cosine of A, right? Adjacent over hypotenuse. Cosine of A equals 6 divided by 11.662. Meaning that A is going to be inverse cosine of 6 divided by 11.662. Over here. And you go and you do inverse cosine of, oh, okay, I'm going to switch it back to math print mode real quick. And I really like math print because it's got the fraction bar, which I think is really helpful for y'all. So inverse cosine, get that fraction bar going, 6 divided by 11.662. And that's, what do you know, 59.036. Okay, there was a little bit of round off error if you'd rounded up, okay, but we're always going to accept answers within one, you know, in the last decimal place. If this was multiple choice, you would not see an answer that was 59.036 and 59.037. Nobody's going to do that to you. So it really, regardless of how you want it, you can do it this way with inverse trig and the number you got, or you can just do it with subtraction, the geometry way. You're going to get the same thing. Alright, the last type of problem I've got for you is an obtuse triangle. We're going to just solve the triangle, right? We're going to find the measure of angle B, we're going to find the measure of angle C, we're going to find the length of side B. Now this is the one that they told you in geometry doesn't uniquely define a triangle. This is the angle side case, right? Remember that? The thing is that in this case, it is going to be just one triangle because we know it's an obtuse triangle. So I'll tell you more about that. And my drawing is not the best. It's definitely not drawn to scale, but I don't think that the triangle you have on your notes is super drawn to scale either. I'm just going off the notes right here. So suppose that measure of angle A is 30 degrees, C is 20 degrees, and A is 20 units, and A is 14 units. Now what I'll tell you, the trick to the obtuse triangle that you want to do every single time is you want to come and on the obtuse angle, you want to drop down and draw like an altitude, I think is what this is called. I believe in this course we're going to call that H, yeah. Now notice if it comes down and it says perpendicular to the side length B, then it's going to be two right angles. And we've actually made two right triangles. And then we're just going to go ahead, now that we've got a right triangle, remember last time we said that if we have one side and one angle and one side of a right triangle, we can figure out everything else. So that's what we're going to do. We're going to split up B into like, I don't know, B1 and B2. And then we'll find each of those. And we'll get ourselves a side length B. And then we'll also be able to find angle B and angle C. So the first step is going to be, okay, well, see, number one says find the length of side A on your note packet. Well, side A is 14. We already know that. Okay. What we need is to find the length of H, the altitude. So H, how would we find that? Well, I've got an angle. I want to know the opposite. I've got a hypotenuse. That's the sine. Okay, so find H. So what I'm going to do is I'm going to say sine of 30 degrees is equal to H divided by 20. If we solve for H, we'll say multiply both sides by 20. H is 20 times the sine of 30 degrees. You can put this in your calculator if you like, but I can just tell you I know what the sine of 30 degrees is. It's 1/2. Look at the unit circled in the next unit, and you too will know that the sine of 30 degrees is 1/2. So, again, you can check me with the calculator if you like, but H is going to be 10. Okay? So, I've got 10, and all I'm going to do is I'm going to replace H with 10. Okay. And now, what I could do is I could find... Yeah, I'm not sure what I was thinking when I listed these questions in the order that I listed them in. But, you know, it's okay. What I'm going to need to do now, I think, would be... I can find the lengths of B1 and B2 using the Pythagorean theorem, which I think is the way to go, personally. You can use trig. You could use, like, you know, tangent of 30 equals 10 over B1, something like that. You could use cosine of 30 equals B1 over 20. Whatever you like, but it really doesn't matter. I think I'm going to go with the Pythagorean theorem right here. And maybe I'll find B2 using trig. Or... no, maybe I'll find B1 using trig and B2 using the Pythagorean theorem. That sounds better. So find B1. Well, I'm going to use cosine. So cosine of 30 is equal to B1 divided by 20. I'm going to multiply both sides by 20, and I'm going to say B1 is 20 times the cosine of 30 degrees. Cosine of 30 degrees is not a rational number, it's root 3 over 2. And again, that's something you'll know in the next unit. So I'm just going to bring up the calculator. Just bring it over here for a second. I'm going to do 20 times the cosine of 30 degrees. And that's 10 root 3. Thanks a lot. Okay, right? I want classic. I want to get that as a decimal. 20. Oh, no, not inverse cosine. No, no. 20 times the cosine of 30. That's 17.321. Okay. And then we can find B2 using the Pythagorean theorem. So I'm going to say 10 squared plus D2 squared equals 14 squared. So D2 squared is equal to 14 squared minus 10 squared. That's going to be, good job for the calculator again. So I've got 14 squared minus 10 squared. That's 96. And then I'm going to need to take the square root of 96. That'll be 9.798. 979. Okay, that's good. So that means that B is going to be 17.321 plus 9.798. I need the calculator for that. I'm not that good. Okay. Slide this over. Oh, no, can't see anything. Okay, 17.321 plus 9.798. That's 27.119. This would be a good time to stop and say, is this a reasonable answer? Yes, that would be a reasonable answer because you know that the side across from the obtuse angle has to be the longest side. Right? And this is bigger than 20 and 14. So this is good. Now, to find angle C, I'm going to have to clear out some stuff. Yeah, to find angle C, I'm going to need to use inverse trig, right? I know that the sine of C, the opposite of the hypotenuse, sine of C is going to equal 10 divided by 14, meaning C is inverse sine of 10 over 14. And you might be thinking, well, why didn't you just use B2 and use inverse tangent? You definitely could have, but I erased B2. So, and in general, I think it's better to use the whole numbers because those are exact, right? B2, the 3 decimal number I had, was rounded off, so you could have some sort of, propagated error there. You wouldn't want that to happen. So use the whole numbers if you have the whole numbers to use. Over here, inverse sine of 10 divided by 14, that's going to be 45.585. So I'll just put that in. And then to find B, I could have done, I could have said that B was going to be like 60 and then figured out what this was using inverse trig. But I don't see any use in that, honestly. I think the way to go is going to be to use that fact that we started with last time, that the angles of a triangle add up to 180. Well, 180 minus 45.585. minus 30 is equal to b. And let's get that calculator one more time. I'll do 180 minus 45 by 85. Oh, whoops. And then subtract 30. And I'll have 104.415. Again, good time to stop and think, does this sound like a reasonable answer? If you think about it, and if I get this calculator out of the way, yes, it does. This is the obtuse angle in the obtuse triangle. Okay, so this looks good to me. And then at this point, 104,415. And at this point, we've got the whole triangle solved. And that's all I got for you for this video. At this point, you just need to practice. If you're having trouble with this stuff, you just need to practice more trig stuff. And if the extra practice problems in the packet are not enough for you, you should come to me because I've got plenty of trig and pre-calc practice stuff.